Hi, we're Group 85 presenting the music player project Matify. My name is Veena Arvind Kumar.
My name is Tian Qidong,
My name is Damon Kwan.
And I'm Luca Caniglia.
So the first component that we have is the drop-down menu with all our songs. And you can see in our code how it works is that there's a switch case that selects the song. And then when you click play, it plays the song. That is done through an if-else statement that states if the music is playing, then you pause it, else you resume it. And if you notice, this slider bar moves ever so slightly as the music goes along. And that is done using a while loop that gets the current time and moves it every 0.1 seconds. And another feature that we have is every time the song is played, this number over here increases by 1. And you can implement this into ThinkSpeak. For example, I have a computer right here that lists a song has been played 5, 3, 2, 2, 2, 1, 4, 4, 3, 7 times. And if I import that, it gets the data from ThinkSpeak. And as you can see, it's all over here. And again, I can share the times this is being played. And this is on ThinkSpeak now. And if I import that data, they're exactly the same. The share button, it takes the frequencies of the songs, or writes it to ThinkSpeak, and then vice versa. The get button reads it and changes the value of each of these counters.
Hi, and for my part, I did first is shuffle button. And when you click it, it will play the random sound. And for the volume change, as you can see, you can change the volume. And also, I did the sound played times. As you can see, it's the kind we play the sound. And that's all. That's all of this code. Just you can see that.
So I worked on the adjust speed function. And when you increase the speed on the discrete knob, the speed of the song will increase or decrease. So as you can see, the pitch can increase or decrease without increasing the speed. And the speed will increase how fast the song goes. As you can hear, the song is going very slowly. I also worked on the reverse switch, so the song will play in reverse when this is turned on. For the speed knob, I used the frequency from the audio read function and multiplied each value by this frequency and then used audio player. For the pitch knob, I implemented a phase vocoder earlier in the code. So here I'm using the resample function. So when the pitch increases, the speed doesn't also have to increase. That's why I implemented the phase vocoder to keep it at the same speed. So I just let it play at its original frequency. And for every other case, I use the phase vocoder and the resample function to make sure that the pitch increases, but the speed does not increase. You can see how the multiple functions I use, 3 different functions in methods so that I could implement the phase vocoder here. For the reverse audio function, I used our Y sound or app.song, and I indexed this backwards so that every time the song plays, it will play backwards in increments of -1.
So the main functionalities I worked on were the forward and back button, the equalizer, the visualizer, and the BPM counter. So first, the skip and backwards button, just basically skip the skip to the next song in the playlist. And then the backwards button skips to the last song. And as you can see, when the next song or the last song is played, the visualizer will show the audio waveform down over here. Then I worked on the equalizer, which it decreases or increases the amplitude of each frequency in the spectrum. So if we play a song and we decrease the 4 frequency, then we can hear a change in the sound. And if we increase the 250 hertz band, then we hear a different sound. And the last component I worked on was the BPM counter. So every time you switch a song, it shows the beats per minute of that song. So no matter what button you press, it will show the beats per minute of that song. And lastly, I worked on the like button. So if you're on a song and you press this button over here, it shows a liked indicator on to the left of the song. And if you go to the next song, then you can do the same. And for the code for these components, the back button was coded with a switch statement. So if you're on one song of the selector, then if you press it, it'll go to the last song or the one before with a switch case statement. And then for the forward button, when you press it, it'll go to the next one with a similar switch case statement. And when each song is selected, it'll show the waveform of the song selected, and it'll show it in the same color as the album art. And that's just coded to every single button. So if you press a song selector, it'll change the visualizer. And if you press the skip button, it'll change it. And if you press the shuffle and so on. So this is the code for the equalizer, and it gets the value from each slider. And then it makes the count +1 if it's not 0. And then it makes a filter for each frequency band, and gets the value of the slider and kind of makes either a band pass, a low pass filter, or a high pass filter. And then at the end, you just add all of them together and divide it by 10, and you should have the output audio. And for the like button, when the like button gets pushed, then whatever song is selected, it'll place a heart next to the song that's selected. I also implemented album artwork and song and artist indicators. So if you press one of the songs in the playlist, then it'll show up with the name, the artist, and the album art. And lastly, our group did a import file button with a database. So if we select this search button, then we have a list of songs that we can play. So we can select one of them, copy it, paste it in this text box, and then we can play it. And also the last thing we did was an open file. So we can open any file from our computer and play it. So I select this WAV file, and it'll display the file name as well.